today's video, we're going to take the plane carousel ride and we're going to break it down today to show you the mechanical principles that go into this in order so that you might be able to build your own different types of automated mocks or whatever. We'll do this in several parts. Just as a quick starter, I like to often have my models use a single motor and a single battery and be able to build everything up from that. And so you'll find that I'll take power off of one drivetrain and move it onto a second drivetrain as we go through so that multiple things are moving along at the same pace. One of the principles that goes into this is a simple scissor lift here, and I'll bring out a scissor lift here in a moment just to show you. But this is basically the thing that the planes sit on, and this allows them to go up and down by pushing on the bottom here. This whole thing will spin. As we push up on this, those planes will lift and come back down to their resting point, and this thing will spin or not spin as it needs to do. Although in general, it's only going to lift when it is in spinning motion. So a scissor lift, for those who don't know, is a simple serialized 4-bar mechanism where when you push on one side, the other side tends to be fixed, like here. It pushes out, and you can see it takes very little motion to push on one side in order for it to increase in size and come back down. You'll often find these in, say, a cherry picker or jack. This is just like your scissor jack basically, although you'd have far less pieces. These are put together pretty simple, and you can probably find 100 or better videos on how to put one together, but it's just a simple mechanism. I should mention, when we say a serialized 4-bar mechanism, what I'm saying is that we have a 4-bar system followed by a 4-bar system followed by 4-bar system on up, and you can create this as high as you want it to go. One of the things I should mention on the carousel lift is that we have a turntable on the bottom. One of the other really cool parts about this mechanism is that we have a gear stack here. And this rotates independently of this shaft here. When it reaches a particular height, we'll engage this gear to start turning the carousel lift. So if I turn this on here for a moment, we will raise the gear and it will engage the gear stack. And that is how the mechanism works in order to lift the aircraft, turn the aircraft, and then return the aircraft back to the ground. Or if you prefer, to lift the car rides, raise the car rides, and return the car rides back to the ground. And basically what you can see here is that this gear here is turning, which is coming from the system in here, which we'll get to in a moment. And this is on a simple lift. This gear here sits on a Scotch yoke. It's important to note when we're looking at the rotational stack that the gap down here means that we won't be rotating the carousel above. And once we do engage with the gear stack, that gear stack is always rotating, so then our carousel will be rotating at that point. But we can lift and not lift whether this is rotating or not. An interesting thing about this gear stack here is it simply sits inside this lift arm here and is held by another Technic plate or lift arm up above in order to secure it so it doesn't have lateral movement. This will also have a lift arm or plate above it to secure it. And in my model, I happen to have a plate for both of these that secure them. For those unfamiliar with the Scotch yoke, it's simply an element that translates a rotational motion into a linear motion. And that motion can either be vertical or horizontal. If you were creative, you could probably even do it at an angle. So I want to take a little bit here to break down the Scotch yoke system I've created. Because of the amount of weight that I have on the carousel, I needed to make sure that it was sort of heavy, reinforced, and can support all of that weight. So I created a system that uses 2 sets of gears and is supported from both sides. The gears work in opposite directions. So after some work, we broke down the build more. We've gotten to just the Scotch yoke part. You can see we've got some reinforcements on the sides to simply reduce the lateral motion when we move the Scotch yoke up and down. Having taken off this side, we can see that we've got just these 2 gears over here that really aren't, they don't do anything other than help support the weight, which was supported with this bracket right here. As we go along, you can see we're getting closer to the Scotch yoke mechanism you're used to seeing. And we've got one going one way and one going the other, but that does help us reduce the amount of lateral motion we would otherwise get. It also allows us to strengthen the forces that we can push up with for the whole carousel itself. And here we're down to just the gear train that drives the Scotch yoke up and down. When we set these, we want to make sure they're in sync with each other so that they're either perfectly up, perfectly down, perfectly together, or perfectly far apart, as whichever direction one goes, the other will go the opposite way. Because the motor was spinning too fast originally and I needed to slow it down for the speed that I wanted my ride to go at, I used a simple gear train here to reduce the speed to something reasonable. Like many other elements, you can look up simple gear trains on hundreds of videos, so I'm not sure we need to go in too much onto that, but that is what a gear train looks like and why you might want to use one. As we continue to dive down into the Scotch yoke off of the transfer case, we come into another worm gear mechanism here in order to reduce our power even more. We use another box here to reinforce the drive so that we don't have shearing forces pushing us off of our gears and get those annoying click sounds. Now that we've gone through the full assembly and or disassembly, you can see that we've used many of the mechanical principles necessary in order to build an automated machine. Hopefully you can use these principles on your own to build your own mocks, your own machine designs, or understand how some of these simple little mechanisms can be used in order to build more complicated machines. In the future, we might discuss how we put this all together as an artistic project and how we brought the elements of design in for the various colors and the palettes and the elements that were necessary for creating what I hope is an aesthetically pleasing ride for my amusement park, and maybe you can use those similar concepts in your own builds. Everything you've seen here you could probably find other places also for building, but this is how I brought all of those elements together from an engineering background in order to build something I find fun and entertaining, and hopefully you do too. Thank you. One of the things we should mention also about all of these engineering projects is that there are many ways to actually build this. You can choose to use other machine elements in order to build your machines.